Hello students, welcome back to my channel. Today I am making a video on previous year's ICSE questions on analytical chemistry. Now in my previous two videos I have already discussed this topic in detail. So if you haven't watched those videos yet, so first go and watch those two videos and then come back to this video for better understanding. So without wasting time, let's get started. The first question is from Icse 2019. Now it has been asked that write a balanced chemical equation for ammonium hydroxide is added to ferrous sulfate solution. So what will happen when ferrous sulfate solution FeSO4 is added to ammonium hydroxide, that is NH4OH, and you have to write a balanced equation. So here I have given a balanced equation. So when ammonium hydroxide NH4OH is added to FeSO4 ferrous sulfate solution, then ammonium sulfate is formed and along with it a dirty green PPT of ferrous hydroxide FeOH whole 2 is formed. Okay, so this is basically the balanced chemical equation. When ammonium hydroxide will be added to ferrous sulfate solution, then ammonium sulfate will be formed, along with it a dirty green ferrous hydroxide PPT will form. Next question is also from 2019 ICSE. Copper sulfate solution, that is copper 2 sulfate solution, reacts with sodium hydroxide solution to form a precipitate of copper hydroxide. State the color of the precipitate form. So here it has already been told that copper sulfate is reacting with sodium hydroxide solution and it forms a PPT of copper hydroxide. You have just to say the color of this PPT. Now the color of this PPT is pale blue. When copper sulfate reacts with sodium hydroxide solution, then it forms sodium sulfate and along with it a PPT of copper hydroxide, and the color of that PPT is pale blue. Okay. Now the next question is from 2018 ICSE. Here a question has been given with 4 options and you have to just choose the correct answer from the given options. You have to say the salt solution which does not react with ammonium hydroxide. The 4 options are calcium nitrate, zinc nitrate, lead nitrate and copper nitrate. So among these 4 salts, you have to say which one does not react with ammonium hydroxide. Basically, calcium nitrate does not react with ammonium hydroxide. So the correct answer is calcium nitrate. Why? Now ammonium hydroxide, you know that it's a weak base. In the video on acid bases and salts, I have already discussed that weak base, ammonium hydroxide is a weak base, and weak base means it forms low concentration of hydroxide ions, OH minus ions. So it cannot react with the hydroxide of calcium. That's why calcium nitrate does not react with ammonium hydroxide solution. So the correct answer is calcium nitrate, the first option. Clear? Next question is also from 2018 ICSE. Here you have to write the balanced chemical equation for the 2 reactions. First one is the reaction of sodium hydroxide solution with iron 3 chloride solution, that means ferric chloride. So when sodium hydroxide solution is added to FeCl3, that is ferric chloride, then NaCl is formed. Along with it a reddish brown PPT of ferric hydroxide FeOH whole 3 is formed. So this is a balanced chemical equation. So when sodium hydroxide reacts with ferric chloride FeCl3, then NaCl, that is sodium chloride, is formed and along with it a reddish brown PPT of FeOH whole 3 ferric hydroxide is formed. And in the next case, what will happen? You have to just write the balanced chemical equation for the reaction of zinc with potassium hydroxide solution. So when zinc reacts with potassium hydroxide, Zn plus KOH, okay, what will happen? Here I have given the balanced equation. A salt is formed. A salt will be formed. Okay. And what is that salt? That is potassium zincate, K2ZnO2, and it will liberate hydrogen. So whenever zinc reacts with potassium hydroxide, it will form a salt potassium zincate and it will liberate hydrogen. This is the balance equation. Clear? Now the next question is again from 2018 ICSE. You have to state one relevant observation. For what? When lead nitrate solution will be treated with sodium hydroxide solution, first dropwise and then till it will be added in excess. So when lead nitrate, the white lead nitrate solution PbNO3 is added or is reacted with NaOH, sodium hydroxide solution, first is drop by drop. Okay, first is drop wise. Then what will happen? Sodium nitrate will be formed and the chalky white PPT of lead hydroxide PbOH2 will be formed. And when this NaOH will be added in excess, okay, to lead hydroxide, then a colorless solution will be formed. Water will be formed, and in total a colorless solution of a salt, sodium plumbite Na2PbO2 will be formed. In those two videos on analytical chemistry, I have discussed all these equations in detail. So just go and watch those videos. So again I am repeating, when NaOH, that is sodium hydroxide, will be added drop by drop, like drop wise, to white lead nitrate, then sodium nitrate will be formed, and along with it a chalky white PPT of lead hydroxide will be formed. And when that same sodium hydroxide will be added in excess in the lead hydroxide, then a colorless solution of sodium plumbite Na2PbO2 will be formed. Clear? Now the next question is from 2017 ICSE. You have to state one relevant observation. For what? For when sodium hydroxide solution will be added to iron 2 sulfate solution, that means ferrous sulfate. So when sodium hydroxide solution is added to green ferrous sulfate solution, then it will form sodium sulfate and a dirty green PPT of ferrous hydroxide FeOH2. So basically you have to write like this, that when sodium hydroxide solution is added to green ferrous sulfate solution, then sodium sulfate solution is formed, and along with it a dirty green PPT of ferrous hydroxide FeOH2. Ferrous hydroxide is also formed. Okay, this is your observation. Clear? Next is question from 2017 ICSE. You have to distinguish between ammonium hydroxide solution and sodium hydroxide solution using copper sulfate solution. So basically copper sulfate will react with both sodium hydroxide and ammonium hydroxide, and you see in both the cases a pale blue PPT of copper hydroxide will form. In both the cases a pale blue PPT of copper hydroxide will be formed. But in case of sodium hydroxide, this pale blue copper hydroxide solution is insoluble in excess NaOH. But in case of NH4OH, this pale blue PPT of copper hydroxide is very much soluble in excess NH4OH, and it forms a complex salt, a deep blue or inky blue color solution of a complex salt, tetraamine copper sulfate. So this is the basic difference. I am repeating once again. Whenever you are using copper sulfate with NaOH and NH4OH, in both the cases it will form a pale blue PPT or precipitate of copper hydroxide solution. But in case of NaOH, this copper hydroxide solution is insoluble. It is not soluble in excess NaOH. But this pale blue PPT of copper hydroxide solution, or pale blue PPT of copper hydroxide, is very much soluble in excess NH4OH, ammonium hydroxide, and it forms a complex salt, a deep blue or inky blue solution of tetraamine copper sulfate. Okay, clear? Now the next question is from ICSE 2016. Here you have to state your observations. When ammonium hydroxide solution is added drop by drop and then in excess in each of the following, in these two cases, in copper sulfate solution and in zinc sulfate solution. So first, when ammonium hydroxide solution will be added to copper sulfate, okay, then as I have already told you, it will form a pale blue PPT of copper hydroxide along with ammonium sulfate, and this pale blue PPT of copper hydroxide is very much soluble in NH4OH, in excess NH4OH, and it will form a deep blue or inky blue solution of a complex salt, that is tetraamine copper sulfate. Okay, and in case of zinc sulfate, same thing will happen. When zinc sulfate will react with ammonium hydroxide, then it will form a gelatinous white PPT of zinc hydroxide, and this gelatinous white PPT of zinc hydroxide is again very much soluble in excess NH4OH, which will again form a colorless solution of a complex salt of tetraamine zinc sulfate. So again I am repeating, in both the cases, in copper sulfate and zinc sulfate, in both this solution, whenever ammonium hydroxide is added, in both the cases what a PPT is forming, and those two PPT is very much soluble in excess ammonium hydroxide. In case of copper sulfate, a pale blue PPT of copper hydroxide is forming at first, and then when excess NH4OH is added, a deep blue or inky blue solution of tetraamine copper sulfate is forming. And in case of zinc sulfate, first when NH4OH is added, it forms gelatinous white PPT of zinc hydroxide, and when excess NH4OH is added, then it is very much soluble and it forms a colorless solution of tetraamine zinc sulfate. Clear? So I think all these questions are very much clear to you. And come to the last question of 2015 ICSE. The question is, to a salt solution Y, a small quantity of NH4OH solution is added. First in slowly and then in excess. A pale blue precipitate is formed, which is then dissolves in excess to form a clear inky blue solution. You have to identify the positive ion in the salt Y. I have already discussed this type of question. Just this question is a slight tricky one. Here a salt solution Y is given and NH4OH, ammonium hydroxide, is added to this. Okay, and it forms what? It forms a pale blue precipitate first. See this one. And then that pale blue precipitate is very much soluble in excess NH4OH to form a clear inky blue solution. You have to just find out the positive ion in the salt Y. This is the salt. Here it has been said that this is the salt Y, copper sulfate. So in copper sulfate, which one is the positive ion? Copper, Cu2+. So whenever copper sulfate is added to NH4OH, a pale blue precipitate of copper hydroxide is forming. This pale blue precipitate is very much soluble in excess NH4OH, which forms a deep blue solution or inky blue solution. Clear? So in copper sulfate salt, which is the salt Y here, you have to identify the positive ion. The positive ion is copper, Cu2+. Clear? I think all these questions are very much clear to you all and you have no doubts. I think so. And still, if you have any doubt, then you can write it down in the comment section. I will definitely try to clear it out. So that's it for this video. And if you think that my videos are informative and they are helpful, then please like my videos. And if you haven't yet subscribed to my channel, then please subscribe and click to the bell icon for getting the notifications immediately for the new videos. And thank you for watching the video. And of course, stay tuned to my channel for more such videos.